name is Olabisi Fatima. I want to continue with my own software demonstration in this video. In my previous video, I showed how to generate the linear regression value and tests and scores to develop algorithms to be able to predict some values, my target value of variable in my testing set. So using my training set, I was able to generate the estimated values of my target variable, which is going to be used on my testing sets to predict the target variables from my testing set. Okay, here I have the widget, my workflow, my orange workflow from my training set, my initial video, which I'm going to also use to, I'm also going to use to for this video on testing set. Like I have this file is my training set. So right now I'm going to get my file again. My file and expand it to doc. And I can just undo this so that we can visualize all the widgets we have. So I'm going to have my file here. For the file I'm going to have here, I need to load my testing set here. So I go to my data bank. I have my commodity prices test set. Here I have values from January 1st, 2024 to April 5, 2024. The set of weights. So let's visualize this in a data table. So like I said, I have this is 2024. Okay, you can set from January. January 2024 to 5th of April 2024. Then here the data set is from 2022 to 2023. From 24th of February and 24th of February to 29th of December 2023. Here I have data I've not used as part of my training set to ensure efficiency of my algorithm, my machine learning algorithm. That is one tool. Then here I do not have the price. Price is my target variable is what I want to predict here. So price is missing right now. So for my I can name this 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 test. Let me settle this testing set. And I can also check some basic features of my data table and the data set I'm using for my analysis. Yeah, I don't have much data set here. So okay, I don't have price, I'll just leave it. So this is not really significant. I'll still go ahead to do some. And I have the correlations too. So let me check distributions. Price is missing here. So I'm just and the part of the thing I need to do, the first thing in any knowledge discovery database process is to ensure that the data is clean, usually missing values. It will affect the efficiency of our machine learning algorithms. So I need to check. Okay, I'll go to remove instances with unknown values. So I'll use my data table which will confirm what I have. Here I have 67 instances, 6 features. Let me check here. 6 features, it was initially 7 here, inclusive of price, but now I have price excluded, so I have 6 features now. It's also 67. Okay, then let me check for outliers, which can also mostly affect my the prediction of accuracy rate of my machine learning algorithm. So I have outliers here. I check outliers here. If I'm using Euclidean distance method. Here I also like to view my outlier and my data table. Right now I want to view the outliers. So here I have 6 tuples with outliers, values that are not different from other observations within the data set. So I would like to concatenate to get in my inliers from analysis here. Good here. So my inliers, just check. Yeah, our variables are then input table source ID. These are class attributes. So I also like to view what I've done in my data table. That table coming up. So since I right click to get, I can just connect the output channel of my concatenate widget to the input channel of my data table widget to check my values, the values I have of my 61 instances minus the 6 outliers, because initially I have 67. Okay, then I can also go ahead to do some explanatory data analytics here. I can check scatter plot again. Yeah, see. I can check the box plots, which should give me my 500 summary here. I do source, but they are not really relevant here, as my target variable is not part of, is excluded from this testing set. I want to predict the value of my testing set. Then right here, I can also check the future statistics, which provides more features as an image. Okay, the color is unknown. Any color open, color change or any other parameter here. Since I don't have price, I'll just ignore this part. So the next thing I need to do is to select column now to ensure that the target variable is blank. So I'm to select my column. I'm selecting the column. Yes, yeah, I don't have target variable. The price is not here. I'm going to predict the price. And the next thing is I'll come in my prediction widget. So my prediction widget, I cannot have anything yet. I'll have to link the linear regression from my training set to the predictions widget and the testing set. So here I have my linear regression with estimated price value for this period. Then I can also have the data table to visualize this. So in the data table, I have this linear regression, and I would like to just the predicted value based on the algorithm developed here from the test for linear regression test there. So I've used that to predict my price variable in my testing set for US rates. So I will check, I have my data sets. I have commodity prices test sets. Yeah, these are the values of my test set, but the test itself, commodity prices test, yes, US rate. Here I have the corresponding prices here. For the test set, I expunged the price column. Here I have, this is my 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 test. I have the price column here. But for the price test set, yes, which I have used for the testing my testing in Orange software, the price variable or column is missing. Here we have my price value. I want to check the predicted values with the corresponding. Sheets. Maximize this. Test set. So I can just cross check the price. Sorry, try to. Okay, this is the date. Let me expand this side. April 5. The predicted value is 569. The actual price is 567. We have some error, some stochastic values here. For on the 4th, 554, we have 556. 3rd of April, 5562. 3rd of April, 554. 2nd of April, 544. 2nd of April, 545. So we have this, which is actually, the difference is very, very little, which still shows the strength of our machine learning algorithm. And I will go back to mine. Here, I would like to check more my predictions right here in the data table. Okay, then let me check my test score. Yes, the first validations we have 10 folds, and it's repeated. The data set is true and tested on 10 different folds. Then the training set size is 80%, and I can decide to increase this to check the effect on my evaluation criteria. And here with an R square of 0.998, it shows that the the model fits and is able to explain a very, very significant portion of the changes in my target variable. Thank you for watching. Bye. See you in my next video.